Recording in.
Hello, everyone. Welcome to ITS 454. Hopefully you guys can hear me. So we're currently recording. We've got the microphone on. So let's just start with a few things really quick. I'm going to open up the calendar, given that we are getting close to the end of the semester, and I just want to make sure everything's all pretty clear. All right, so I'm sharing the calendar here. Okay, you can see it's the calendar. We are now at the other, we're done with spring break. So we basically have this schedule here. So as you can see, I've updated the calendar at this point and it's ready. So just a few things to note that are really important that you're aware of. Did we do a exam 1 in this class? We did, right? All right. Okay, so a couple of things. I'll start kind of at the end and I'll work my way back. So this is finals week. So our exam during finals week will be on May 3rd. Okay, so this class meets at 6. So the exam would probably be from 7:15 to 9:15. It'll be a similar exam to the formats we've done before, virtual. I'm actually traveling that week. You know, it'll be just virtual basically. Okay, just similar format. Okay, but just be aware of that. So mark your calendar, May 3rd, 7:15 to 9:15, and it'll be a virtual exam. Then we have this week, April 26th. Now in this class, we don't have a project, or you do have a project, but you don't have a presentation is what I mean. You need to just demo to me. So the very last day to do your demos is April 28th, but I strongly recommend that you start doing your demos. There's a group that has already demoed like a good portion of the project, okay? So it's very important that you start scheduling that, you start completing some of the tasks. Remember that there's basically 3 milestones, right? The first milestone is just being able to ping through the network. You built it. Second milestone is working through all the cases and implementing all the ACL rules. And remember that in the document somewhere in there, I say implement 5 new rules that I didn't ask for specifically. So make sure you do that as well. And then the third phase would be implementing some type of a VPN. However, we can do that. That's the only portion that you're allowed to use a GUI interface on. So you can, but it has its challenges. Okay, so we'll see how that part goes. But that's really ultimately the project, basically the 3 portions of it. Are there any questions about the project? Nope. All right, so just remember, I know I wrote presentations here. I didn't want to change it because I always write that, but it's really just you doing your demos to me, so not to the whole class, because we all kind of did the same thing. All right, and then basically, so it's wrapping up these 2 weeks. And then if you notice here, we usually have our exam on April 5th, which would be week 12. However, I'll be traveling on April 12th as well. So, you know, we'll have a class on the 5th, and I've just moved the exam by 1 week, right? So push it back. The exams are comprehensive, so if anything, the exam should be easy points for you guys, okay? And they include everything that we've covered from beginning to end. Again, the exam on April 12 will be virtual, same format as exam number 1, but obviously additional content will be in there, including maybe possibly questions from the ASA project, okay? So make sure that is there, but please mark your calendar for April 12 as exam number 2. And that really just leaves us with 3, if you will, these 3 weeks of topics, okay, that we have left that I'll be lecturing on Tuesdays. Remember, as usual, you have Thursdays to work on the project. Keep in mind, basically, I would strongly suggest that you start demoing, you know, like by May 31st, okay? Everyone should have demoed at least the first phase, the ping through, okay? And then the ACLs and everything, because it's, you know, we're approaching the end of the semester. Questions? How many labs do we have left for the semester? I'm getting that question. We only have 2 labs left for the semester. That was the last thing I was going to speak of. As you know, we're kind of doing the labs on Tuesdays. Basically, I have these 3 weeks marked as the topics. Today, I'm doing like the last big lecture, which is introducing the IP tables. All right, so IP tables is actually a pretty good way of talking about firewalls, because you know it's the Linux firewall. We get to talk about a lot of the details of it, and then you will have a homework assignment. This lab is best done with the Raspberry Pi. Okay, it's you get more out of it. For those of you that are fully virtual, I mean, you could do a lot of the rules just on VMs, but you don't get, and there's actually a link here, I think. Set up a VM as a router. You see this one? So for those of you that are, I guess, virtual, which is very few, you can take a look at this one and make it into a router. All right, but this lab in the past, as we've always done it, is done better by using the Raspberry Pis. Now, all that documentation for converting a Raspberry Pi into a 2-network interface router is provided. It's all on Brightspace, very clear. And we have the equipment here next to the Cisco equipment. Today, I'll do the lecture. I'll do the lecture of how yeah, so I will do this. I will look into the LKM code and to see why it's not working. So we'll get that fixed up. All right. And then, as I said, just to wrap up, we're going to cover IP tables today. You know, just do that lecture, and I'll assign the homework for this, which is basically 10 IP tables rules. So you have to implement 10 firewall rules. And the document is also on Brightspace. Then we have next week, we have firewall egress evasion and proxy firewall. So this is an easy lab. Should be very straightforward. So we'll cover that. And then on April 5th, basically the last topic, which will be cryptography and networking, which is basically VPN, right? So we'll usually, I save the topic of TLS for this one. Kind of just talk a little bit about what TLS is, which is SSL, which you already know from 350 anyway. So it's just a protocol. All right, and that's basically the semester as we have it left, right? So these are the 3 topics. There will not be a homework for the VPN and in crypto, given that you're implementing that in the project. So really, to answer the question, there's only 2 labs left to submit. Okay, the IP tables lab, which is 10 rules, as I said, and the firewall egress and proxy firewalls, which is just 2 problems. Any additional questions? All right. Yeah, and then as far as the C code, we'll take a look at that towards the end of class. If somebody can just like show me the errors, you know, we can try to debug it. All right, but let me go through the IP tables lecture today, given that it's kind of important, and I want to get that topic sort of out of the way. All right, so let's see, just to make sure, recording, audio's on. All right, so let's go ahead. Switch over. Now, question for you guys in the audience there. Did anyone get the code to run, I guess, the LKM code? Did anyone find what the error was and got it to work? Nobody? All right. All right, so we'll take a look and see what it is. I'll have to see what the debugger is saying. All right. When we compiled SNFX, did we compile it with the LPCAP file? Do you guys remember when we compiled SNFX that we do something, you know, GCC SNFX dash LPCAP? And when you guys compiled this, did you compile it with LPCAP? I'm trying to think if that might be the reason why it's not compile. I'm just thinking, since you're bringing this up, I'm trying to work through the problem, but we'll look at it. If any of you have it handy and you remember how you compiled SNFX with that LPCAP, go ahead and run it with that. I would say SNFX was using LPCAP to deconstruct the packets. Well, in LKM, we are deconstructing packets as well. It's not like we wouldn't use that library. You know what I mean? You know, it's. And does the make file include the LPCAP file? Yeah. All right, I'll have to check it out. But yeah, let's do the lecture for a little while, because otherwise debugging this thing could take hours, right? So let's do the lecture and then I'll take a look at your problems and I'll be able to think about it tomorrow if we don't solve it today. All right. Okay, so let's go ahead then. And the first thing is, let's take a look at Brightspace actually. So I'm going to share Brightspace. You know, as I usually do, I'll start with what the lab entails, and then that way you guys know what it is that you need to look for. So let's take a look at content. And as you can see here, we're currently, this was the last module that we did, software firewalls. So as you can see, we really just have these three modules: IPTables, Raspberry, Seed Firewall Ovation, Squid, and Software VPN. Okay, so the two that have a homework are these two. And so we're gonna look at IPTables, which, as I said, is the Linux you know, main firewall. Okay, so there's a few documents in here, as you can see. Read through all these documents because these documents have a lot of useful information for you. We're going to do something. One of the problems is port forwarding. So I think these are the problems. So here they are. This is what you need to submit basically for your homework assignment. So problems are block ICMP, and all of this is, as I said, these have to be things that you implement in IPTables. So number one, block ICMP packets going into the router. Number two, block SSH requests to a specific IP address out on the internet. This is usually my one server I have on the internet that you can use for the class. So block SSH requests to this or other from inside network. You will have to do one that is port forwarding from B, access SSH service on A. Okay, I'll explain how this one works a little bit more. Number four, block HTTP traffic going from A to a specific IP address by IP address. Number five, implement a rule that blocks telnet and logs that block to a log file. So basically the logging is the important thing. Block a denial of service attack on the router from the inside network. Very important for this rule, disconnect the PI from the university's network, or if you live, as just common sense, right? Don't do a denial of service attack on an actual network. So do it in a control environment. All right, but what's important here is you will need to set up an IPTables rule specifically to block this attack, okay? So you have to think a little bit about that one. Number 7, drop traffic by MAC address for a PC in the internal network. And then number 8, add and test a rule to block access to a specific subnet. So as you can see, these are similar to other ones that we've done, but it should allow us to practice a little bit more and for you to think about ACLs. Okay, so this is literally the IPTables homework. And so I will explain some of this logic today, okay? All right, so that's the main document. And then the other documents are for implementing or configuring the raspberries. You have these documents, so IPTables report, right? You can see this was developed some years ago, but it's got all the configuration that you need for those specific models, and it describes how to make them into routers, basically. All right, so just make sure you read through that one. And then RPI router, so we have this document. Notice also that when you read through it, you will find some examples that are similar to the problems I've given you. So if you read these carefully, you're already solving the problems, okay? So definitely read through it, as it will be, should be helpful to you. In the solutions one, it even has some scenarios that could be similar to the questions. I modified them a little bit, but there's only so much I can modify. Right, so take a look at these. You can see here it's got the configuration, but also some test cases of how to add the rules to IPTables. So you can read through that one. So these 3 documents are basically for that, okay, for configuring the Raspberry. And then we have, there's this document, port forwarding. This is one thing I will, so all these things, as I usually do, right? So I'll explain this, but you already have the notes. So you can, it's got the rules and everything. So you can use it as reference. But I'll go over this today. All right, and then finally, of course, we have the 2 PDFs, which are the seed labs. You can see here, or this is not the seed labs, but this is just port forwarding. As I said, this is something else that I will be explaining, okay? And then there's some rules here. So all of this I'll explain, but you have it already available to you. All right, so we can discuss it. And then finally, there should be a seed labs in there. Yeah, I think it's this one, the PDF. Right, and this PDF here, it's basically the LKM one, but now we're looking at, I split this really into the LKM part and then the IPTables part. So here, what you can see, we don't need Docker for this lab, or we shouldn't need Docker. You can see this is all the LKM, right? So that's the thing you guys are having trouble with. So that's for the previous lab. But then we've got this section here for IPTables, task number 2. So really, I included this. You don't have to do the problems in this one, okay? Just do the 8 problems that I've given you in that Word document. However, I think it would be very useful to read through this document. It's very well explained. It's a lot of what I'm going to explain today, but it's got the nice commands printed out. So it's certainly a very good reference. For, it's got, the tables and everything. It's all explained. And, it's got some interesting ideas in there. So I strongly recommend that, it's got little tricks or little things that you will need. Like I'm highlighting this. And if you think carefully, you probably can figure out that this could be used for one of the rules. And so, limiting network traffic. So I wonder what that could be used for. All right, so take a look at this document. It's a very good reference, I think, for the lab. Okay, so these are the documents. These are your reading assignments, and basically now what I'm going to do is I'm just going to go over on the whiteboard and kind of describe IP tables. Okay, so that we can understand the basic logic of it and how it should work. So before I begin, are there any questions? Set up my tablet. Here, so let's go to the whiteboard here. All right, so you should all be seeing the whiteboard. So we are going to describe here IP tables. IP tables. So in Linux, you probably used UFW a lot, right? So you've used UFW, and if you remember in 372, we actually do a lab on UFW. But really, UFW is just I think it stands for the uncomplicated firewall. And really what you can think of it is almost like an interface. It's an interface to basically the underlying firewall of Linux, which is called IP tables. Okay, and IP tables is really just a sequence of tables, as it implies here, that allow you to, whenever you have a computer, right? We learned in the actually in the LKM lab, and when we look at the C code, that the C code needs to hook to these like a pipe, right? So there's like a pipe in the kernel space. In the kernel space, there's a pipe where the packets are flowing, right? So the packets are flowing. Packets are flowing. Okay, and so our C code needs to connect to these pipes. Now, as it turns out, there's actually different kinds of pipes into the machine. Okay, so really, you can almost think of it as if this is a router with two network interfaces, there's actually a pipe that goes through it. There's a pipe that goes into the device, and then there's a pipe that goes out of the device. So that's the best analogy that I can give you. And this is important to understand because this is going to affect your rules. All right. So that's why the IP tables lab is kind of a nice one, because it really allows us to dig really deep into these kinds of concepts. Okay. And so we will need to take a look at that. All right. So let's think about it. So in IP tables, we have what are called basically, so we have something called chains, and then we have something called tables, right? And, tables are something like the filter table. So we've got table, filter. We've got the NAT table. Now, you've been using a NAT already, right? Network address translation on the Cisco ASA. Right, and then the chains are basically where you implement the rules. So here you have some things like the input chain, and then you have another chain which is pretty important, which we will use in one of the problems, called a pre-routing chain. Okay, so we have several chains that we can use, and so we have to really, because of this nature of, is it going through, is it going in or out of the machine, right? We have to kind of tie this movement to specific tables or chains. Okay, so that's basically the idea. So within the filter table, so the filter table is actually connected to the chains. Okay, so we can see here that the filter table has actually three main chains, which are going to be input, output, and forward. Okay, these are the input chains where you will add your rules. So the rules go in these depending on where the packet is going. Okay, depending on the final destination, let's say, of the packet, that's how you have to think. So usually when students get confused with the rules, you know, one of the main problems is they're just not grabbing the right chain. And although it seems pretty straightforward, I see this quite a bit, right? So the filter table, which is where you want to implement your rules, has at least three chains. The input chain, which we can define it as containing all the incoming packets. So it's got all the incoming packets. Then we've got the output chain, which relates to all the outgoing packets. And then we've got the forward chain, which it processes all packets being routed through the machine. So all routed packets, okay, need to go through this chain. If you don't select, if you put a rule that should be on the forward chain, but you put it in the input chain, the packets will go through. You'll never get a hit on the hit count, and you'll never know what's going. And you may think, you know, you may think it's just a rule. Your rule may be correct. It's just in the wrong place. Okay, so that's a very important concept in IP tables. And you can also have user-defined chains. So you can add it like this. We can say user-defined chain. So the great thing about IP tables, you know, unlike Cisco products, etc., you know, it's open source, right? So it's going to be open source, and it gives you a lot of opportunity to craft it. Another important table, as I mentioned before, was the NAT table. You will be using this one in this lab. As I said, we're going to be doing an exercise called port forwarding, right? And so for that one, we will need to use some of the elements of the NAT table. So, sorry. Okay. So in this case for NAT, now you've already been experimented with an issue related to NAT in your project, right? So you guys are familiar that in the project you have to implement NAT, network address translation. You're doing this on the firewall from the internal network, so the internal network to the outside network, right? And you're mapping IPs. You're creating a pool. This is usually where you're using the commands NAT and global, right? So we've talked about that quite a bit. All right, but the NAT table actually is made up of three chains, which are the pre-routing. So the pre-routing, so these are chains. Pre-routing chains we have, and then we have post-routing at least. Okay. And really what these mean is, if you want to think of it as, okay, this is the computer, right? And as a packet is going through, before it hits, let's say the chain that has the rules, there's going to be another, or the pipe that has the rules, right? There's going to be another little pipe, right, in front of it, and that's going to be the pre-routing. So that's basically the idea. You have a packet. Before you actually go to the routing phase of it or the ACL phase of it, you want to run it through something called a pre-routing. And what happens with the pre-routing is it allows you to change aspects of the packet. Do you guys see that? It allows you to change the nature of it and where it should be going, etc. So this is going to be something useful that we're going to try to implement when we do port forwarding. Okay. So just So one good way of describing, so now let's go back to input, output, and forward, right? So let's provide a little bit more context in the computer. So imagine this is the router. So that's why I said, if you're doing this on your VM, for instance, without treating it as a two network. So here's the thing, when you do a virtual machine, you only have one network interface, correct? You usually just have that. But in the ASA, you have two network interfaces. You guys know that. This is connected to switch 1. This is connected to switch 2. That's exactly how this is, it's best to better understand these chains. I would recommend, not using like the VM approach, okay? It'll, I've seen that students get confused when they do that, and this becomes, the clearest. So that's why, we've gone to the expense of buying the what are they called? The Raspberry Pis, so that you can do this assignment like that. All right, so in the Raspberry Pi, you'll be able to create two network interfaces. One is already a network interface. The other one is actually a USB, but we have the adapter, and just by changing a little bit of code, that USB becomes the second network interface with the adapter, okay? So we want to think about our problem like this. So the three chains where you add rules are input, output, and forward. So again, how do you identify inputs? So if the routing decision, so let's talk about input. So I'll just kind of mention it, right? So if the routing decision is that the packet is intended, if the routing decision is that the packet is intended for the machine in which the packet is being processed, then the packet passes downwards into the input chain. So I'm going to change color here, and I'm going to say, well, if the packet ultimately will be processed by something in the machine, in the Raspberry itself, then this is input. Okay, so this would be input chain. All right. Now, if a program, now the second scenario, output, think of it this way. If a program running on the computer sends a packet, then that goes to the output chain. So in this case, again, we can think of a process. I'm going to change to another color. So here we have another process. This process generates a packet that goes out into the network, but it originated from this machine. This is the output chain. This is usually the one chain where you have less of a concern, right? But this could happen. For instance, if you have, what's one scenario where this could be important? Well, if you have like malware, right? So you have malware as a process running on your computer, isn't it? That means it originates from the computer, and then you got packets going, right? So output, it would be useful in that role, okay? So keep that in mind. And then the third one is the processing does not happen, the processing of the packet, the final processing of the packet does not happen on the machine, or the initial creation of the packet does not happen on the machine. Instead, both of those happen outside of the machine, okay? So that type of traffic is for the forward chain. So if the packet is going to another interface on the machine, then forward. So usually I think that's a good definition of it. So you want to always ask yourself the question, is this, well, that's a bad comment. Is this packet hitting both interfaces? Do you see that? That's a forward. So when does that happen? Well, it happens when the packet came from here, right? Comes from here, but it ends up outside of the network. So it's just going through the router. So that is going to be for the forward chain, okay? So a classic example of this is, in your ASA, pretty much all traffic has been like that. So you've got switch 1, you have switch 2. And so what's happening here is, you have client PC, right? So client PC, and then you have DMC over here in your scenario. So you open a browser or you ping, you're going through the router and ending up here. So it's hitting this network interface, this network interface. That means that that packet should be going, any rules should be going to the forward chain when we're using IP tables. Is that clear for everyone? This is usually the point where I see the most confusion when implementing the rules. Okay. All right, so I'm not hearing any questions. It sounds like you guys get it. All right, so that's some of the logic there. And then there's a few other tables where there's a table. So I'll just kind of briefly mention this one, although we're not actually using it. There is a Mangle table in IP tables, which is a specialized. Let's just say for specialized packet alteration. Now you should already know what that means because we've done spoofing. We started with sniffing and spoofing, so you know that you can grab a packet, copy it, change it, right? So pretty much that same idea, but now IP tables does it by itself, or does it as part of the system. Okay. Now there's one called finally the raw table. So I'll kind of briefly mention that one as well. And the raw table is basically for configuring exceptions. Okay, so this is for exceptions. So again, these are things that are more like, prototypes, that kind of thing, where you're testing out things. So you're configuring exceptions. So this takes priority over other tables. All right. So basically, it goes first, and it allows you to run specific things to do an exception of a packet and just let it through, or just block it, etc., depending on your experiment. All right, so that's kind of just a basic idea, high level of IP tables. And then now that we've discussed just the basic overall idea of IP tables, we can just get into the syntax of the rules, right? So that's really where, but as I said, what's important of everything that I said is really to understand the differences between input, output, and forward, which are the three that you will be using. Okay, and then now to kind of get a better understanding of the syntax of how to implement the rules. So I'll do some examples, most likely. These are just, generic examples, not so specific to your homework assignment. All right, so let's see. All right, so let's say that we want to, so how does it work, right? So it's command line, right? So you're in the Raspberry Pi. So I'll start there. All right, so you're in the Raspberry Pi, right? And so remember that the Raspberry has Raspbian, that's described in the document. That's a Linux kernel. Okay, so basically it's like you're in Linux. Okay, so think of it that way. A smaller footprint of Linux. Okay, and so whenever you want to reach IP tables, you just run the command IP tables. Now, quick question, would you need to be in root or do sudo, right? So take a look at that. But basically the command is IP tables. So let's say that, we're going to think of, I'm just going to kind of list out things that you can do with it, which I think are the most important. I'll just use the generic greater than symbols to indicate the terminal instead of, $$ or £. I'll leave that to you. So the first thing you probably want to do when you get on IPTables is you want to look at it, right? So you want to look at, now I want to stress, you probably use UFW, right? So you use UFW, enable, disable. I usually, when we're testing things out, I'll say, disable UFW, etc. This, as I said, is just a quick way of interacting with IPTables, but in this lab, you will not be using UFW, okay? So just be aware of that. So you will not be using UFW, and everything you can do directly in IPTables, so you don't actually have to invoke UFW at any time. So let's say that we want to see a table, so to see tables, you can do IPTables -T and then the specific table that you want to look at. So for instance, you can do filter and then -L, and that just shows you more information about it. You can do another table. So we could do IPTables -T, and you can look at the mango table, for instance. Okay. And so that's an approach that you can take. Now, guys, very important, especially with the Raspberry Pis. Remember, I think I've mentioned this before, bricking. Okay. Bricking is it's a term, basically indicates that you've blocked yourself from the table. When could this happen? If students in the past, I've had this happen, they break the devices. Okay. We used to have these the WRTs back in the day, and those were they would brick those basically. Now, when can you brick? So it's very important that you're aware. When are you most likely to brick your device? When you start adding rules into the input chain. Why? Think about it. Input refers to all traffic coming in to the device. What's traffic that goes into the device? SSH. Do you guys see that? If you start adding rules that drop packets, from a certain IP, all IPs drop, that kind of thing, you will brick yourself. Okay. So be very aware of that. All right. So think always about the rules that you're going to enter before you add them in. Okay. Now, usually there should be in the etc folder, there should be a file called maybe firewall.user or something along those lines. That file, excuse me, it would be recommended to create a backup of it. And then it usually has a few entries in it, but usually at the end of it, you can add your own rules. And if you do that, that's a permanent way of putting rules into the firewall. So just be careful with that. Every time that it initiates, it'll load those rules. All right, so let's take a look at things that we can do. So the way that I'll run through this exercise is basically just to give you some like scenarios, right? So let's think of a scenario. All right, so let's think of the first scenario. Let's say, and this might be a problem that I gave you. So let's say a problem, example. So we've got an example. Let's say that we want to block an outgoing service. So an outgoing service such as SSH. So it's already dangerous, right? I'm not saying the direction here, and if you implement this rule initially, right, you're going to block SSH. So it's what I'm saying. Be careful with this kind of thing because you'll break the device. All right, so here we have, then we want to do this. So how do we implement it? we should go to IPTables, and then the generic syntax should be that, first of all, actually, the first thing you want to do is view the current status of the table itself, right? So that might be the first thing you want to do. So you're going to do IPTables-L, and then, let's say input. Do you see that? So you look at input, and then you can say -n -- line numbers. This is a very nice feature because it actually tells you every entry, but every entry gets an index, like a number, like 3. And so that's useful because whenever you want to remove an entry from the chain, if it's 3, you just say delete 3. You see that? And it makes it very nice and handy. How to do this. Also, you can say where you want to insert the rule. So let's say, for instance, that you have the chain, right? And the chain looks kind of like that. 1, 2, 3, 4, right? Remember that chains are also, I should mention this, and this is really important, they're sequential. So that is, they hit this one first, and this one, then that one, then that one. You see that? So if they don't find a match, they keep going until they find a match. So that's why that usually the last one, when you've gone through all the explicit denials, you kind of let it through, right? Because it didn't hit anything specifically. But if it, let's say it hits that one, that's where it stops. And it does whatever this says, whether it's pass or let through or something like that. All right, but anyway, that's important. They're sequential. The other thing that's important to mention is, let's say that we're going to add a rule. So it's important, rules are important because where we add them is important. Because let's say you have a rule, you want to say a rule, block SSH here, but by this IP. But then this rule says, allow this IP always. Then it's going to hit that IP and never hit the SSH part. Do you guys see that? That sequential part is important. So that's why order matters, right? Now, if you had inserted the SSH before the IP, then that makes sense. Okay, so in IPTables, the strategy I would say is step 1, view the table with line numbers, take a look at how they work. And then number 2, then once you know the number, let me switch back to red over here. So now you're going to do IPTables. You're going to do IPTables, and then now -I. And what the I implies is insert. So now you're going to insert in input, right? And where do you want it? Well, I want to insert it at 2. So what does that mean? It means that the new line will go to 2. And what do you think happens to the line currently at 2? It doesn't wipe it, pushes it down. Yes. So it's kind of like you're like in the change, you're putting it in that, squeezing it through, and everything moves down. Okay, so that's an important one. If you wanted to do the other thing, that what he said, Dakota said, delete that one and then insert it there. Okay, so you can also do that. So we'll look at delete in a second. So in this case, all we're doing right now is we've said IPTables insert in the chain at position this, but we still haven't specified the rule, right? So we still need to specify the rule. So that just comes after. So you can say something like -p TCP, right? So we're specifying that this only relates to TCP packets. And then we're going to say something like -- the port, which is destination port. And then what port number would go here? 22, right? And then you have to tell it what you want. So in this case, -j drop. Do you guys see that? And that's basically, it's as simple as this. So block an outgoing service such as SSH. So this is this correct? So does this actually do what we want? So we added it to the input chain. Yeah, it says outgoing, right? So how do we define what would be outgoing in terms of a router? Leaving it. So that means you're already logged in this machine, in the router, and now you want to SSH to another machine, right? Another interpretation that you could make of outgoing could be that it is outgoing in the sense that it came through here and it passed through there, and now it's outgoing. Outgoing as in outgoing of the internal network to the outside. Do you guys see that? This is important, right? This little language, because if I say outgoing here, and if you give this answer, that will be incorrect. Okay, so just bear that in mind. So in that case, now let's say that you wanted to implement, now if you implement this rule, actually, what may happen is, if I look at it as it's written, IP tables, insert input, TCP, what's going to happen? Destination port is the key. So remember, just like you learn in your sniffing and spoofing labs, you have to think that you're the computer and you're currently inspecting that packet. So you're like, you know, imagine you're a human, right? And you're looking at this packet. Destination port 22. It means it's going to that port on the machine. So the laptop is listening on port 22. You see that? This is what you have to understand. And so you're going to look at this as destination port. So actually, if I read this, this is going to block, let's say that I have another PC, all SSH into that machine. That's what this rule will do. You guys see that? Very important. Okay. So, and just, so I'm going to erase this. So instead, the rule, the correct place may not be input, but instead could be forward. And it should be all uppercase, by the way. Okay, so this one should be forward. So now analyze it again, right? So you have to analyze it again from the context here. So the chain is going to look at a packet, right? It's the forward chain, so it's this pipe. The packet is right there. It's going through the device with a destination port 22. Okay, so this packet, when it goes through this pipe in forward, yeah, it could be a packet coming from here going out into the network. Do you guys see that? And so in that case, it'll drop it. So it will not allow the SSH connection. And that would be correct. Got it? Make sense? All right, so this is the basic syntax. Okay, so we'll just do a couple more examples of this. So that was blocking outgoing SSH. All right, so let's do an incoming. So now let's think about this. Block an incoming port. Right, so block all requests on port 23. So all incoming port 23. Okay, so in this case, I'll skip. I'll just do it one more time, I guess. IP tables. You're going to view. So -L. So which chain do we use? Input, forward, output. Input. Okay, so we're going to use input here. -N -- line numbers. Okay, and then now we're going to add the rule. So it's going to be IP tables, and then -insert input. Where you put it, that's, you have to check, right? You have to see what rules are in there, because, as I said, the sequence does matter a lot. And then TCP, and then it's going to be -- dport, and this is going to be number 23 -J drop, and that's it. And that's how it works. Let's see what else. Now, let's block port 23, but only for one IP address. All right, so we're going to do another rule, another example there. So this one we're going to say to block port 23, okay, on only one IP address. All right, so here then I'll skip the viewing part, so just IP tables dash I, port 23 and only one. So let's assume it's still the incoming. All right, so IP tables dash I input 2. So I'm just still staying with that one. And then dash P TCP. But now we want to specify the address, right? So maybe the source address 1.2.3.4 dash dash D port 23 dash J. Oops. Drop. Does this make sense? And so that's the other example that we can take a look at for dealing with IP addresses. Okay. All right, so this one should be interesting. Let's say that we want to, let's say, block ICMP packets, right? So remember, we did in one of the previous exercises that we have ping requests and ping replies, right? So we can, as long as we drop one of them, right, we're breaking basically the flow of ping, right? So we can look here at an example, block ICMP ping request. All right, so ping request. So this is going to be IP tables, or sorry, IP table. No, IP tables. All right. IP tables dash I. In this case, this would pings usually would be going to that machine. Let's say that machine just wants to drop old ping. So you're going to say input. Let's say dash. Sorry, not dash. Let's say just for whatever reason, we're going to insert it at position 3 dash P. Protocol is now ICMP, right? Remember, this is that protocol. And we're going to say dash dash ICMP type. And that's going to be echo request. Right, so for those particular types of packets, then the function would be dash J drop, and we just drop the packet itself. That's it. So it's pretty simple, right? So it's not complicated at all. Let's see. So now I'm going to give you guys one to solve. So I'm going to draw the scenario here. And then this is the internet. That's the web. And then you have a web server here. And this web server is 184.168.26.138. Okay, so you're trying to get to that. This has yeah, this is a web server. So let's say this is a web server. And so here you have a computer, PC, and it's got a browser, right? and this computer opens the browser and wants to go to that IP address directly. Do you see that? So now go ahead. This is, of course, the Raspberry. This is the firewall, Raspberry Pi. So now block outgoing IP address, outgoing traffic to a specific IP address. So let's say block outgoing traffic to 184.168.26.138 from here, right, from the internal network. So how would you do it? So I'll say this: block outgoing traffic to 184, which is A. This is easier, so from B. Okay, so this one's A, and then this one is B. All right, so write the rule. How do we do it? Any ideas? On the forward chain, right? So that's like the most important decision, right? So IP tables. Okay, and then what did you say? Insert?
Yeah, we need to know where.
Right. Say 2. Mm-hmm.
Depends on if you want to block HTTP or HTTPS or.
Well, currently it just says block outgoing traffic to that IP address. So just yeah. We're not saying by service or anything. Just that IP. So how do you do it?
I don't know how to specify.
Okay. Okay, and then dash J drop, right? Exactly, and that's it, right? So this is the logic. So as you can see, the homework shouldn't be that difficult. This is the entire approach that we want to take. Questions so far? Nice. Not hearing any questions. All right, so let's try a little bit more. So you've probably seen me writing something like this. So usually want to display the status, right? Or view. Now, if you want to just view the entire IP tables, you want to run the command display status. And so in this case, you can do IP tables -L -N -V. So -L stands for list rules. So list of rules. -N should be for show ports and IPs. Okay, and then -V, I think it's verbose. So basically, that's the way that you can look at the whole IP tables status of the device. All right, you can also add -- line numbers, and then you will get the information, but it'll have the numbers in them, which is kind of nice and useful. Okay. All right, so for it now, if you wanted to do a specific chain, as we said, you can do IP tables -L input -N -V. Okay, so that's the example for that. So yeah, so I knew I was forgetting something. You also, when you've entered a rule, eventually you want to get rid of that rule, right? So you want to delete the rule. So that's an important command to be aware of. Okay, so that should be so deleting a rule. Delete a rule. Okay, so in this case, first you want to look at the index, obviously. So you're going to say so get the index first. So it's going to be IPTables -L. Let's say you're looking at the input chain. And then, -N -- line numbers. Okay. And now that you view the table and you've got the list of numbers in front of you, you're going to go ahead and delete the one that you want to delete. So to delete, you can do IPTables -D, and then input, which would be the chain, and then you need to specify the number that you want to delete. So in this case, let's say you want to delete 4. In this case, it will delete that entry, right? And then it just moves, closes the gap, basically. Any questions? Nope. Clear? All right, good. All right, so we've covered viewing and the chains. So let's see if I have a few additional flags that you might need for the assignment. Now, obviously, other protocols, if we go to another page, just like we did -P and we did TCP, right? There, we also did ICMP. You can also do UDP, just like that. If you want to mark states, another set of flags for that would be basically the state flag. So you would do -M, -M state, and then that would be followed by the specific things that you want. So in this case, you could do -- state, and it could be things like established, like when you have a three-way handshake. So these are all the parameters that you can define. Now, as far as the commands, the -J commands, so there's -J, and usually you're going to do drop, but there's also, of course, what would be the opposite of drop? Accept, right? So there's accept. Is there a third one? Reject, right? And the reject one, what does it, we defined it, I think at some point, what does reject do? It basically tries to send a message, right? Doesn't just like, just drop it, but it tries to send something additional. Okay. We covered that. Now, another thing that another flag that's also important is the interface flag -I. And this is important because when you have two devices, you may have two interfaces, right? So you have the -I, and let's just say, I'm just going to make up a number here, ETH0, right? So you need to know, for this, you need to know the specific interface of the device. However, I think in the Raspberry Pi documents, that's very well clearly stated in there. Yeah. And so you can just get that reference from there. I forget off the top of my head what they are. ETH1 and 0, yeah, so it sounds about right. All right, but the flag -I will be important. In particular, probably the hardest problem here will be port forwarding because it requires a couple of rules. In particular, with port forwarding, we have the scenario, port forwarding is only needed in which direction? From the outside in, right? So classic example of this is your house, right? So you live here, you have all your machines here, but then here you're in school, you want to access your server inside your house, so your connection is going to be coming from the outside in, right? So that this interface is the one in particular that needs to hear the knock so that it allows things to go through. All right, so we'll talk about that one in a second. But I'm just trying to give you a whole bunch of little things, just to kind of illustrate how some of these things can be done. So another thing that you might want to do is you might want to accept packets from a trusted subnet, for instance. So in that case, you would do -S or D, but you can just put in the net mask, basically. So you can do 192.168.6.0 right? And that should allow you to set up subnet as well. Or you can do the 255, so that's another, should also work. That's here. Okay, so that one should work. You have one for MAC address. All right, so for MAC address should be, the flags in question should be -M MAC, and then MAC source --MAC source, and then the specific MAC address. So in this case, I'm like 00:50:FD and ... right? So you guys get the idea. All right, so these should be the flags. Everything else is the same, but just those should be the flags for it. Another flag that you can try is the -SYN flag. So --SYN. So you can inspect for that one. That one, obviously, it's only for when you have TCP packets. All right, so these are, I think, the main flags that you would need for this problem. So are there any questions so far? Pretty easy. Okay, pretty straightforward. Let me see if I have any. I think that's everything, to be honest. And then, of course, there should be a lot of information in the documents that I gave you. Yeah. All right. So that's basically it as far as the problems. So we have some time. So I say we go over that problem that you guys had. All right, there's still one more thing I need to cover, which is the port forwarding scenario. Obviously, that's a little bit more involved. It's already in the notes on Brightspace, and you can start reading through that. However, I'm going to save that one for next Tuesday. Okay, so start working. You have, so just to kind of recap, if I go, you know, I've given you all the material here, a lot of the flags, and then the basic utilization of IP tables. And really what's important is to be aware of, you know, the direction, inputs, outputs. Remember, again, I'll stress the problems that you need to complete are in this module. So everyone should be looking at the Brightspace now. If I click on this one, you can see IP tables, Raspberry Pi, have all the documentation. These are all required reading. And the problems are here. I think I've given you enough that you can complete all of those, except possibly for the port forwarding scenario, which is a little bit more complex. So we will talk about this one next Tuesday. All right, and also next Tuesday we'll do the proxy firewalls and firewall evasion, which would be a lot of fun. How to do that. All right, so we have some time, and I know you guys had some questions on the homework assignment. So let's actually do that. So would anyone, let me stop sharing. I'm gonna stop the recording here, okay?